Okay, shall we start? Is it clear for the other those who join with the online? The board? Sure, I believe that you can see because they do not talk. If they have a problem, they have to inform. Right, I take this one. Normal distribution and standard normal distribution we discuss. We want to start confidence and significance area. Today, right? Now let's take confidence and significance area. Confidence and significance. Significance again, you can say critical. Critical area. Right? Confidence and significance area or regions. Confidence or significance means at the beginning of the estimation, I said that we are using parameter. We want to estimate parameters using sample statistics. Statistic means the measures with regard to sample, English letters, measures which represent population, parameters, Greek letters. Using this, we want to estimate parameters, right? Then confidence means in our normal distribution, this is center point, that is our mean. Our population parameter is expected according to a particular probability. Between this range, my population parameter will be, that region is called confidence. This is the area of confidence. Outside of that confidence region is called significance. Significance. Confidence means a particular probability. 95% I have sure. That is confidence. If it is what is the probability of significance, that is 5%. If you want to estimate with more confidence, 99%, 1% significance outside of the confidence region. 90% confidence if you use, then it is 10%. If you use 68% confidence, this is 32% significance, like that. But most probably we consider these three. Out of these three, also we give priority for 95% and 99%. Then confidence means the particular parameter will be within the range according to some probability, that is confidence. Outside of that region is called significance. Confidence and significance regions are separated from these points. These points are called critical points. Critical points. These critical points are having values. Those values are called critical values. These critical values are taken from standard tables. It's a table, T table. When you use later regression models for forecasting, F table. From these tables, we take critical values. This is the confidence. This is the significance. Then 95% confidence means these 2 points, 1.96. 99% confidence, these 2 points will be 2.58. 90% confidence, these 2 points will be 1.65. 68% will be 1.00. According to Z distribution, you need to understand how to take them from Z table, Z distribution. Right, firstly write down the meaning of this. Population parameter will be within a region will be within a region according to some probability. That is called confidence area. That is called confidence area. That is called confidence area. Outside of that, confidence area is called significance area. Confidence and significance areas are separated from critical points. The values of critical points are called critical values. These values are obtained from standard tables. Such as Z table and T table. You can see Z table. This is your Z table. This is your T table. Z table confidence is provided. That's why the shaded area. T table shaded area is significance. Z and T. Normally F table when you use later, significance area. Chi-square table, significance area. Therefore, the highlighted area is represented from the table. You need to understand. Confidence, significance. Visramba Vesesia. Confidence, significance. Right, standard values, the standard confidence and significance frequently we use in our research, in our test forecasting, hypothesis test. Later we take hypothesis test after the estimation. These values 95%, 99%. But further you can use 90%. That's you. Don't use 68%. These three, most probably. Out of them also give priority for 95% and 99%. Okay. This is confidence and significance. Right. Then further write down. According to the confidence and significance areas, we can identify critical values. As given below. as given below. As given below. Right, first note down this type of graphical presentation to understand confidence and significance. Then mark critical points, these two, their values, critical values. Critical values. Step by step, we learn all things, confidence, significance. Right. Confidence, 95%, balance is significant, 5%. No doubt these two. But pay priority for these two in your studies, 95% or 99%. If it is not given, always we consider 95%, 95%. Your research also use 95% or 99%. Right, this confidence and significance regions or areas, hypothesis test, I explained there, acceptance region is rejection regions in hypothesis test. But here estimation, therefore confidence, significance, significance. Confidence, significance. Right. By using this table, you can identify according to these figures. Especially we consider these three. We want to identify these points, these values. I will show how to identify these values from this table. Right under that, write down. According to the different confidence level, according to the different confidence level, critical points and their values can be identified as given below. Right. 95% I take first. 95%. You identify like this. 95% confidence. Confidence means this area. Significance, this one. Right. 95%, this is a symmetrical distribution. Symmetrical, well said. If it is from this point x bar, you take as a distribution, it will become 0. Right? Mean value. X value is also mean value. X bar, then this part will become 0, means that is 0. We know this time. Right. 0.95 equally you have to assign, if it is when you divide equally, what is the value? 0.475. Okay. 0.475. If it is 0.475 area, 0.475 area, confidence equal be assigned. That's the way we do, right? You also do like that. Here, right, 0.95 divided by 2, 0.475. Why 2 facts? Symmetrical distribution. Samamitika vyaptya. Symmetrical. Right, this is confidence. I got confidence. Significance 0.05. 5% means 0.05. Decimal points I take. Again, you want to equally assign 0.025. Right, if it is 0.025 this side, 0.025 this side, equally you assign. It's a table, T table, symmetrical distribution. Equally you have to assign. But if table, chi-square table, right is cube distribution. Only one side, positive side. At that time I explained F distribution. Now identify these are symmetrical distribution. Equally you assign. Then when you take 95%, 5%, the value is 100% means 1 probability. That's why we noted down the attributes or characteristics area covered by the x-axis and the frequency curve will be 1. 95%, 5%, 1, 100%. Now see this table. Table is providing only one side, the shaded area 1. This distribution net table you can see, it's a table you can see only this area shaded. You need to identify that same portion belongs to this side, but only negative value will be changed. One side is provided. It means that 95% means table is providing 0.475, 47.5%, half of that. When you check some tables, this side also says all this. If it is this 0.5 has been added. That's why we can see that value also has been added to the table. Is a cumulative table. Cumulative. Samuchita table. But most probably we use this table. One side is shaded. You need to understand same side there to the left side. Right. Now I want to check from the Z table. Z table, when you take that Z table, it provides Z value here. The other decimal points of Z value here. Inside of the table or body of this table, you can see probability. Probability means that is the confidence is provided. Confidence. Right? It's a table. All these probabilities, confidence, the same area. One side of. Here is it values. The balance decimal points. Right? That is a table. Now I want to check What is this critical point? Check 0.475 when you can find critical value, Z value, that is the critical value. 0.475 means you can check 0.4750 because 4 figures are provided here. Now check 0.4750 is where? Now when you check 0.47, gradually it is going there, 0.43, 44, 45, like that you can see. 0.4750, 4744, 4750. This is the point. Isn't it? That value is 1.9 here, 6. That is the critical value. 1.96, 1.9 here, 0.06. That is our value. .4753. Okay, table. Then you can see here 1.96, right side positive, left side minus. That's the way we identify. Okay, right. Therefore, you need to clearly understand and note down 1.96 minus 1.96. Any clarification, please ask. That's why normally 95% confidence 1 plus or minus 1.9 is written as critical values. Plus or minus 1.96. Okay, let's check 99%. 99%. I will take. Then I draw a distribution similarly. Same distribution. No need to measure the distance. Right. This is your Z is for 0. This is the confidence. Significance. Significance. 99% confidence means 0.99. Equally, I assign 0.9 means 4. 19, then 1 left, 19, then 2, 9, 18, 5, 0.495. Otherwise, 4 decimal points, you can take 0.4950 like that. Now 0.495 here, 0.495 here. If it is significance means 0.011%. When you divide equally, 0.005. 0.005. Then I take another color. This value 0.005, 0.005. Now I want to check from Z table this point. Only one side is provided. Then check 0.4950 is where? Now 0.49. 47, 4929, 4946, 4949, 4951. Right. You can see these two values. 0.4949. Next one is 0.4951. Our value is 0.4950. Isn't it? Now check what is the gap between these two. 4951, gap is 1. 4949, again gap is 1. Therefore, you take upper one. If there is a small gap, you select that one, equal one, next highest value you select. That is most probably we do, even though you selected this one, it's not a problem. But out of this gap, take the minimum gap. Equal value, take next highest. Right, then 0.4951, I check 1, 2.508. That's why we say 2.58. 2.58. Minus 2.5. Clear? Need to understand, because without this, no hypothesis test. Right, now check 90%, it's enough. No need 68% because we are not going to use this one. Use 90%. Identify from the table. I got this one 99%. Right, 90% confidence if you take same table, same distribution, same table. Confident, significant. Confidence 90%, 0.90 divided by 2, 0.45. Otherwise, 4500. Then you can see here 0.4500, 0.4500. The 45 you can write, no problem. Significance 10%, 0.10 divided by 2, 0.05. Therefore, here 0.05, 0.05. You have to check from table 0.4500. 4500. Zero point 4500, you can check from your table. 45. 4495, 4505. But we need 0.45, equal distance. Therefore, we take upper one, 1.65. That's why 1.65. Therefore, these we normally we keep in mind, because it's a table when you apply, that value does not change based on the sample size. Always it is fixed. So then you need to understand confidence, significance, and critical value. 95% confidence, 5% significance, plus or minus 1.96. 99% confidence means 1% significant, plus or minus 2.5. 90% confidence, 10% significance, plus or minus 1.65. This three. But if you take 68% also, 32%, you can see plus or minus 1.06. Okay. Understood? Confidence, significance, and critical values. This is the way we want to take critical values. Sample size 30 or more. Use these figures. 95% confidence, 1.9. 99% confidence, 2.5. Like that, you use in your research. A small sample, we want to go for T distribution. I explain size of the sample. T table, small sample less than 30. Then we want to learn more terms. Degrees of freedom. Database. I think that you got 95%, 99%. This confidence, significance, and critical values. Then it will be very easy to test the hypothesis. Hypothesis means when you are doing forecasting by using regression models, correlation analysis. Correlation we want to use T table. And regression models we have to use a table. Right? Therefore, you need to understand very clearly. Right. Then confidence and significance, that is very clear. You understand. Then we want to take sampling distribution. Sampling distribution. Near the VR. Near the VR. Sampling distribution. I clear is. Sampling distribution means this is your population. You take several samples. Sample 1. Another sample. Like that you take samples. More and more samples you take. Suppose that this is m number of samples. You see. After selecting samples, you calculate sample statistics. Sample statistic you calculate. Like that. But the problem is this. They cannot see. This we want to take. Color things. Not clear. Only one page. Right. Now using that sample, you calculate sample statistic. Suppose that X bar you calculate. Sample means X1 bar, X2 bar, X3 bar, M bar. Sample. Sample statistic. Sample statistic. Sample means. Or proportion also you can calculate as a percentage or in decimal point proportion अनुपात. When you calculate the sample statistic, the distribution which consists of the sample statistic is called sampling distribution. X1 bar, X2 bar, X3 bar, likewise Xn bar. That is sample mean distribution. Sample mean distribution. If you calculate a proportion, good item, bad items. Proportion. P1, P2, P3, Pm. Proportion. For male female employee sample ratio, male female, male ratio 60%, 72%, 30%, like that you calculate. That is sample proportion distribution. So these are the sampling distributions. After selecting several samples, you calculate sample statistic. The distribution which consists of the sample statistic is called sampling distribution. Most probably we use mean value. In our syllabus also we have calculated this means. Therefore mean estimation and mean hypothesis test you want to do. So then sample mean distribution, proportion sample proportion, standard deviation sample standard deviation distribution. Like that you can take. Okay. Standard deviation you can calculate here also. If the mean is there and data set is there, you can calculate standard deviation, isn't it? You can't, I can. And do descriptive statistics. That's right. Especially you want to learn this one. Right. The meaning we write down first. After selecting several samples, from population, sample statistics can be calculated. Sample statistics can be calculated. The distribution which consists of these sample statistics is called sampling distribution. If we calculated sample means, that is called sample mean distribution. That is called sample mean distribution. If we calculated sample means, that is called sample mean distribution. Right, you can note down like this. Sample 1, sample 2, sample 3, like that. Right. It's about proportion. This is sample mean distribution. Sample mean distribution. Sample mean distribution. Right, sampling distribution near the व्याप्ति, मध्यम व्याप्ति, sample mean distribution. Right, because you need to understand. Always it is difficult to take several samples. You take only one sample. Based on that, you want to take the decision, estimation, hypothesis test by taking one sample. Or maybe you are taking two samples from two populations. Right, but understand the meaning of that. There are methods to approximate. Next is central limit theorem. We need to understand it is related to sampling distribution. Central limit theorem. Madhya Seema Pramita. Central limit theorem. Central limit theorem. Central limit theorem. Central limit theorem. This says that if you selected several samples, those samples are large. First sample also 30 or more. Second also 30 or more. All are 30 or more. This is also 30 or more. Right? This sample also 30 or more. Large sample. After taking large samples, if you calculated sample means this distribution, that distribution will be normally distributed even though your population is not normal. Sometimes population may be left skewed or maybe right skewed. But sample distribution, sample mean distribution will be normally distributed. It is explained by central limit theorem. Again, it says when you calculate the mean of the sample means x double bar, mean of sample means, that is very closer or equal to population mean. It means that mean of that, this is population mean equal. These two attributes are explained by central limit theorem. Sampling mean, sample mean distribution will be normally distributed. Mean of the sample means x double by equals population mean mu. These two attributes. Clear? Right. If anybody asks what are the two attributes of central limit theorem? Sample mean distribution will be normally distributed, though population is not normal. Second, x double by equals mu. Very clear? Right. Clear? Never to be in me. Right. They can normal appearance second meaning. Right. Always are you like that? Right. You are not willing to talk, no? After the lecture, you talk. Okay, right now. Central limit theorem. If we select several large samples, several large samples, within bracket write down n 30 or more. Right? N 30 or more. Several large samples. To calculate sample means. Following two attributes will be provided. Following two attributes is provided according to this theorem. First one, sample mean distribution will be normally distributed. Even though population is not normal. Right, under that write down like this, x1 bar, x2 bar, x3 bar, then xn bar, right, normal distribution, with safe distribution thing. Right. That is first attribute. First attribute, sample mean distribution will be normal. Second, this is first one, the second. Mean of the sample means. Mean of the sample means. Mean of the sample means equals population mean. Equals population mean. Right. Second is double by equals mu in notation. Right. Central tendency, if you want to further know, you can write like this, right? You can draw mu S1, S2, S3, Sm, but sample mu 30 or more. That is great. One sample like a theo with value no need equal. One sample 30, another sample 45, another sample 33, no problem. 30 or more. That is explained by central limit theorem. All these terms you need to understand before the calculations. Okay, central limit theorem, that is very clear. Next, we want to take standard error. Standard error. Sammata dose. Standard error. What is meant by standard error? Standard error means when you take sample means, calculate. By taking several samples, you calculate sample means. After calculating sample means, you can calculate the standard deviation. Isn't it? Standard deviation you can calculate. Therefore, standard deviation of sampling distribution is called standard error. By taking several samples, you can calculate sample statistic. Using this sample statistic, you can calculate standard deviation. That standard deviation is called standard error. Therefore, how we interpret standard deviation of sampling distribution is called standard error. नियति व्याप्तियක සම්මත අපගමනය සම්මත දෝෂය වේ. Standard deviation of sampling distribution is called standard error. But practically, you take one sample. More samples you don't take. Therefore, there are methods to calculate standard error using one standard deviation. We want to practice that. But theory, sampling distribution is standard deviation. Right. Now we write down standard deviation of sampling distribution. Standard deviation of a sampling distribution is called standard error. Is called standard error. Practically, it is difficult. Practically, it is difficult. Practically, it is difficult to take many samples. To take many samples. Therefore, standard error can be calculated. Standard error can be calculated considering standard deviation of population. Standard deviation of population or a sample. Standard deviation of population or a sample. Standard deviation of population or sample. Standard deviation of population is also difficult. Population එක study කරන්නේ Therefore, it is also difficult. Therefore, sample standard deviation we consider. Right, how you calculate the standard error of one sample? Standard error we want to calculate. One sample you calculate like this. The standard error equals population standard deviation. If you have, you take that divided by square root of sample size. Difficult to take the standard deviation of population. Therefore, you take sample standard deviation divided by square root of sample size. Practically, we use this one. Practically. If you take two samples, standard error we calculate standard deviation, first one is square variance divided by 1 plus second sample variance divided by 10 to square root. But it is standard deviation of population difficult. Therefore, what you do, take S1 squared over N1, S2 squared over N2 squared. Therefore, practically you consider these two. That's the way we calculate standard error in one sample and two samples. Because your estimation, you want to estimate population mean, population difference. Population mean difference. Hypothesis test for population mean, hypothesis test for difference of population means. These two. Right, this is the way we take standard error, one sample, two sample. Standard error. Taking examples we practice. Right, practically we use it. They are practical part. S1 is squared over N1 plus S2 is squared over N2 is square root. And if a data set is there, I think that standard error you can calculate it. Because you know descriptive statistics. You are fully aware about descriptive statistics, isn't it? If I ask any question, I think that you do. Therefore, I don't ask. Practically, it takes time. We can, but it takes time. Therefore, we take the standard deviation of sample, one sample. Right, example right now. Standard deviation of a sample, standard deviation of a sample, standard deviation of sample, size of 49, size of 49, size of 49 is 1.4, is 1.4. Calculate the standard error. Calculate the standard error. Standard error S over square root of sample size. Practically, we won't use like that. Standard deviation 1.4 divided by size of the sample 49 square root. 1.4 square root of 49 is 7, then 0.7. Standard error 0.2. Okay. Right. Right. Another one we can do, write down this example. A standard deviation of two samples. Standard deviation of two samples. Size of 50 and 60. Size of 50 and 60 are respectively 2.1 and 3.2. 2.1 and 3.2. Calculate standard error. Calculate standard error. Calculate standard error. Find standard error. S1 squared over N1. S2 squared over N2 square root. 2.1 squared over size of the sample 50 plus 3.2 squared over size of the sample 60 square root. Right, now take your value. The value is 0.508. Right, 508. Okay, that is standard error. You got the idea to calculate. Right. Then we want to go to margin of error. Margin of error. Some of the look in the article margin of error. Margin of error. Right, margin of error means you want to take both critical value according to confidence or significance as well as standard error. Combination of these two is called margin of error. Right, in estimation and hypothesis, you want to use both. Combination of critical value as well as standard error. By using that margin of error, some tables have been developed, right? Later you refer. Right? Morgan table, Craig Morgan table. Have you heard? Sample size Craig Morgan table. Margin of error in right. Now we write down combination of critical values. Combination of critical values to confidence or significance. According to confidence or significance. And standard error. Is called margin of error. Is called margin of error. Multiply the critical value. Multiply the critical value by standard error. By standard error. to calculate margin of error. To calculate margin of error. Example right now. Right. Otherwise, first write down margin of error equals critical value multiplied by standard error. Then example. Whatever I have given as note, you can see margin of error means critical value multiplied by standard error. Right. Now take example. Standard deviation of a sample. Standard deviation of a sample. Size of 64. Size of 64 is 4.8. Is 4.8. Standard deviation of the sample size of 64 is 4.8. Calculate margin of error. Calculate margin of error at 95% level of confidence. At 95% level of confidence. At 95% level of confidence. Margin of error, critical value 95% confidence. What is the critical value? 1.98. Isn't it? If the confidence is given 99%, you use 2.58. This is 1.96. 9 times. Multiplied by standard error. One sample standard error, how we calculate? S over square root of sample size. Right, now I calculate here is 4.8 divided by square root of the sample 64 square root. That's it. 1.96 into square root of 64. 8 means 0.6. Multiply 1.96 by 0.6. 1.96 multiplied by 0.6. 1.176. 1.176. That is my margin of error. Clear? That's the way we want to take margin of error. Then we want to take degrees of freedom. Degrees of freedom. Degrees of freedom. Right? DF, that is degrees of freedom. Degrees of freedom, when you are using a table, ICR table, E table, you want to use DF, degrees of freedom. Degrees of freedom means number of values which can vary when restrictions are placed on data. In hypothesis test, we say number of values which can vary in calculated test statistic. In another word, we can say how many times you are having with options. Isn't it? Number of values which can vary in calculated test statistic or number of values which can vary when restrictions are placed on data. දත්ත වලට බාධක තියෙනකොට ඔක කොච්චර දුරට පොඩ්ඩක් එහෙම වෙන්න පුළුවන්ද වෙනස් වෙන්න පුළුවන්. Small samples when you use it happen. That's why in T table you can see here DF degrees of freedom is given according to the size of sample. But 30 or more it is lying on is a distribution. Therefore, 30 or more you use, it's a table, it is fixed. 95% 1.96, it is fixed. But in a small sample, when you take 20, 95% confidence, one critical value. Then size of the sample 25, another value. That's why degrees of freedom. Number of values which can vary. From examples you need to understand further. Right. Therefore, first write down degrees of freedom like this. Number of values which can vary freely. Number of values which can vary freely. Which can vary freely. When restrictions are placed on data, is called degrees of freedom. In another way, number of times which may have options. කොච්චර වාර ගානක් තියනවද තේරීම් සහිත. Like that, right? Further write down. When we use small samples, T table should be applied. T table. This T, not cup of tea. T table should be applied with degrees of freedom. T table should be applied with degrees of freedom. Right, degrees of freedom is that. අවස්ථා කොච්චර තියෙනවද තේරීම් සහිතව ඒක degrees of freedom. කියන්නේ සුචලන අංකය degrees of freedom. සුචලන අංකය. දැන් එන්නතු මේක නිදහස් උපාධිය කියලා එහෙම කියන්නේ නැහැ. සුචලන අංකය degrees of freedom. Okay? Right. I will show one sample if you take degrees of freedom is calculated in -1. Two samples if you take degrees of freedom in 1 plus and 2 minus 2. If you have more, we want to consider ANOVA. ANOVA we learn later. Only one sample and two sample you need to understand. Right. Then we write down. Degrees of freedom is calculated. As given below. Right. One sample in -1. Two sample in 1 plus n2 minus 2. That's the degrees of freedom. That example right now. Calculate degrees of freedom. Calculate degrees of freedom. If the size of sample is 20, the size of sample is 20. Right, degrees of freedom, 20 minus 1, 90. That is right. Another one. If the size of two samples are, if the size of two samples are, or the size of two samples are 10 and 50, 10 and 50. Calculate the standard error. Calculate degrees of freedom. Calculate degrees of freedom. Here, 10 plus 15 minus 2. 25, 23 degrees of freedom. 23. 23. Right? Clear. From another example, I will show for you to understand. I said that number of times you are having option is called degrees of freedom. Suppose that you are going to work. For example, I take you are going to work Monday, Tuesday, Wednesday, Thursday, and Friday. For these 5 days, you are having 5 shirts. 5 shirts or frogs, whatever. Right? 5 shirts. You are wearing. First day, Monday, out of these 5 available. Therefore, 5 shirts you can. Do you have options? Do you have options? Yes. 5 options. Then one shirt you keep aside the second day. Then how many shirts you are having? 4. You are having options. Third day, 3. Do you have option? Yes. Thursday, you have option. 2 options. Yes. Last day, no option, only 1. Isn't it? Therefore, you only one, no option. If it is degrees of freedom, 4, n minus 1. Clear? That is the degrees of freedom. Especially small samples, you want to use that. Now see, here a small sample, when you use degrees of freedom, you can see 1, 2, 3, like that you can use degrees of freedom. Accordingly, these critical values will be changed. But T table is providing right side value, this one, that is significance. According to that significance, we want to find from T table. Clear? Right. Then write down this example. If the size of sample, is 15, if the size of sample is 15, identify the critical values. Identify the critical values at 5% level of significance. At 5% level of significance. Right. Even though it is said confidence, T table when you use, you want to convert it to significance. Significant. 5% significant. The examiner may be saying at 5% significance, but you want to use result table, then you know 95% confidence. Irrespective is the provider, 5% significance means 95% confidence. Result table confidence, T table significance you want to practice. Right? But T table also can be provided for confidence. But most probably we are using these tables. Right. Now take size of the sample is 50. Then you can take critical values at 5% level of significance. Is that table we know? Then I take my critical values to identify from T table. 5% significance means I know that 95% confidence. Right, here 0.025, 0.025. This is significance. 95% means 0.475, 0.475. That is my confidence. This is 0. Now you want to find this value from T table. T table. From the T table, identify. From your table, here provided significance value. Column you can see degrees of freedom. Degrees of freedom. Here you can see T values, critical values. Critical values. Those are T values. T values. That is the table. Degrees of freedom. This is your significance value, that probability. The surface or the body of this table is the T values, critical values. Is a table you can see critical values this side. Is a critical value, balance is a critical value. That is the Z value. Here probability, that is the confidence. T table, probability is this one, significance. This is degrees of freedom. Here you can see critical values, those are T values. Understood? Right. Clearly understand. Right. From T table, take. I want to take 0.025 from the table. Significance 0.025. Degrees of freedom n minus 1, 15 minus 1, 14 degrees of freedom. From 14 degrees of freedom from your table 0.025 degrees of freedom 14, identify that value. This is your critical value. Right, 14 degrees of freedom. Here 0.025, 2.145, 2.145. Then 2.145 minus 2.145. But it's a table 1.96. T table we use therefore 2.145. But that's why a little bit change. When I see me 1.96 is changed, 2.145. Small sample. But large sample when you take, it is lying on the Z table 30 more. That's why. Right, if the size of sample is 10, 9 degrees of freedom. 9 means then what happens? 9 here, 2.262. Okay. Right, that's the way, keep in mind, because large sample you apply Z, small sample you apply T table. Practically you want to do like that. Right, that's the way you identify. Right, next one we want to study types of estimation. Types of estimations. What are the types? Estimation, what the other types of estimation. Point estimation and interval estimation. Lakshamaniman, Prantaraniman, two types of estimation. Right. Then we write down in point form. First one, point estimation. Point estimation. Point estimation. Lakshamaniman, Kalakshayana. Second, interval estimation. Interval estimation. Prantaraniman. Interval estimation. Point and interval. Right, we take first point estimation. In your research, in your examinations, you don't want to do point estimation. It is very simple. We want to do interval estimation. Statistical package, they also do interval estimation. Point estimation means sample statistic you take as a population parameter without doing any adjustment. No any adjustment. If you got sample mean 20, you say population mean 20. No any adjustment. Therefore, it is very less important. Right. Now we write down point estimation. Sample statistic is estimated as the population parameter without doing any adjustment. Sample statistic is estimated as a population parameter without doing any adjustment. That is called point estimation. This is less important. In comparison to interval estimation. Because you think that this is my sample mean, I think yes, my population mean this one. Example, you test sample, then you can see average weight X bar 50.2 kilogram. Then you say, yes, my weight of the product is mu. That is also 50.2 kilogram. No any adjustment. But interval estimation you want to practice, that is highly recognized. We have confidence or significance, all these we consider. Right, then we take interval estimation. Prantaraniman. Right, now we write population parameter is estimated. As a range. We consider sample statistic, confidence or significance, standard error, confidence or significance, standard error, and margin of error. For interval estimation. In our research or business, we apply interval estimation. Therefore, you want to practice interval estimation. Your research, do that. Statistical package, they do interval estimation. Because we want to take sample mean, not only that, critical value according to confidence significance, then the standard error calculation, the combination of these two margins of error, then as a range you estimate. You can say like this, average weight of my product will be 49.8 kilogram and 52.6 kilogram. I have 95% sure. That is 95% confidence. Or 99% confidence. Like that you say. Therefore, as a range. But here just this value point. But this is interval, right? Interval, right? Example, write down. Example. Average weight of the total production. Average weight of the total production. Average weight of the total production will be between 49.8 kilogram and 52.6 kilogram. 52.6 kilogram. And further right, this has the 95% confidence. This has the 95% confidence. Like that, the confidence, with the confidence. If you want to increase 99%, you can take confidence. You can do that. But most probably social studies, management studies, or the businesses, we use 95%. 95%. A medical treatment, we increase that 99%. Right? 99%, like that. Because accuracy of the vaccine. Accuracy of the vaccine, 99% confidence. See, I'm sure. Injection right? Therefore, 99% we increase, but 1% there's a chance for the patient to be dead. Or otherwise, we increase that confidence further 99.9% increase. But social, management, business, or when you are doing studies about the people, 95% it is okay, good. That's okay. But then what to estimate? Not estimate something, that's we want to start the calculator. What to estimate? You want to estimate to estimation of population mean, second estimation of the difference of population means, these two, right? But then we write down first one, estimation of population mean. Estimation of population mean, first one. Estimation of population mean. සංගහන මධ්‍ය න්‍යෂ්ඨමේතු කරන්න ඕනේ. Second, estimation of the difference of population means. Estimation of the difference of population means. Estimation of the difference of population means. සංගහන මධ්‍යන අතර වෙනස අන්තරය estimate කරන්න. These two. For the hypothesis test also we do same thing. Estimation of population mean, hypothesis test for population mean. Estimation of the difference of population mean, hypothesis test for the difference of population mean. Statistical packages are providing independent sample t-test and one sample t-test. These two tests are provided for hypothesis test. Hypothesis test for population mean, one sample t-test. Hypothesis test for difference of population means independent sample t-test. It comprises Levin's test as well, right? These tests we use in our research. Right. Later you practice it as a package as well, right? Later. Right. Now we want to start the first one, right? Estimation of population mean. Estimation of population mean. Right. This means that this is your population. Population. You take a sample. This is your sample. If the sample size 30 or more, large, then you know it's a table to be applied. If the size of sample less than 30, that is small, you apply t-table. When you apply t-table, degrees of freedom n minus 1. You calculate sample mean x bar. Based on that, you want to estimate population mean. That's what we. This should be estimated by using sample mean. 30 or more applies a table, otherwise use t-table. T-table degrees of freedom n minus 1. You I know that you know. Right? You are aware. And that's why I discuss critical value, confidence, significance, standard error, margin of error. Okay. Right. That's what we want to do. Right. First we write down before starting the calculation. From the population, we select the sample. Select the sample to calculate sample mean. Within bracket x bar. Using sample mean, we estimate population mean. Within bracket mu. Greek letter. If the size of sample is 30 or more, that is the large sample. Set table is applied. If the size of sample is less than 30. The size of sample is less than 30. That is a small sample. T-table is applied. With degrees of freedom. T-table is applied with degrees of freedom given by df equals n minus 1. Right, if you use 4 steps, the calculation is very easy. Right. Use the following steps. Step 1. Calculate to identify sample mean. Right, x bar. First decide x bar. If a data set is there, descriptive statistic, you can calculate. Otherwise, it will be provided. Take that traffic. Right. Step 2. Decide the level of confidence or significance. And identify critical values. If it is not given, use the 95% confidence. Use the 95% confidence. Right? If it is given, you can use that. Otherwise, use 95% confidence. 95% confidence is a table if you take what is the value 1.96. That value. Calculate the standard error. Calculate the standard error. Standard error. Sample standard deviation divided by square root of sample size. Because population is standard deviation, we cannot see. Sometimes when you are reading articles, it may be given like this also, simple sigma over square root of sample size, that is also same. But practically you can't take standard deviation of population, that's why sample we use. Fine. Last one. Estimate the population mean as follows. X bar plus or minus upper limit, lower limit. Z table, if you use critical value, you write Z alpha divided by 2. Because 95% confidence, 0.475, 0.475. This Z alpha over 2 means 1.96. No, we got taking two sides, that's why. Right. Alpha this side also we divide. Normally this is the alpha. Alpha over 2, alpha over 2. That's why we write Z alpha over 2. Multiplied by standard. This is the way we do estimation. Estimation of population means we do like this. Right now we can start the questions. First question. The average height and standard deviation of a product is 64 and 2.5 inches respectively in a sample size of 100. Flat. Estimate the average height of total production at 95% confidence. Question number 1. X bar average height and standard deviation of a product is 64, right? X bar 64. 64. 95% confidence, that is second step, 95% confidence, large sample 1.96. 1.96. So size of sample 100. 31. Standard error S over square root of sample size, standard deviation 2.5 divided by square root of 100. Square root of 100 is 10, that is 0.25. Then finally I estimate X bar plus or minus Z alpha over 2 multiplied by standard error. X bar 64 plus or minus 1.96 multiplied by 0.25. .96 multiplied by 0.25, 0.49. Plus means 64.49. Subtract 9 1 10 4 5 5 5 10 1 left. Right, what can you say? I have a 95% confidence. So average weight of the total production will be this range, 63.51 kilogram and 64.49 kilogram. 95% sure. Out of our total production, 95% will be within this range. That's fine. If you want to increase 99%, 1.96 will change as 2.58. Because result critical value 99%, 2.58. Then this range goes beyond. Right. Now we write interpretation here. Average weight of the total production. Average weight of the total production will be between 63.51 kilogram. 63.51 kilogram and 64.49 kilogram. 64.49 kilogram. This has the 95% confidence. This has a 95% confidence. Otherwise, 95% of the items will be within this range. Now practice other questions. Another question take a practice. Now take second question. The average weight of a product is 20.5 kilogram with a standard deviation of 5.3 kilogram. The sample size of 50 large. Estimate the average weight of the total production at 95% confidence. Question number 2, X bar. In the sample 20.5, 95% confidence, 1.96. Standard error, 5.3 over square root of 50. Then estimate X bar after the minus Z over 2 into standard error. 20.5 plus 2 minus 1.96 into 5.3 over square root of 50. Right here, 1.46. 21.96. 19.0. Okay, this range. Right, that's the way. Very easy. Calculation is easy, but without understanding those terms, is it? That's right. Now, question number 3. A researcher has done a study to examine the usage of internet by school children, selecting the sample size of 50 students. The study was carried out, right? Selecting the sample size of 50 students, the study was carried out. Results indicated 11.5 average usage hours with a standard deviation of 3.5 hours. Estimate the average usage hours of the school children at 95% confidence. Now it is very clear, you can do estimation. X bar 11.5, 1.96. Standard error 3.5 square root of 8. $11.5 plus or minus 1.96 into 3.5 over square root of 8. That range 95% sure. Fourth one. If the selected size of the sample is 20 students, estimate the average usage hours of the school children at 95%. But consider here you selected 50. But here it says that consider 20 students if you have selected a small sample. Normally when you take 20 students, mean value, standard deviation, they also will be changed. But here for practicing, consider same values. Size of the sample we change as 20. X bar 11.5. 95% confidence I won't use, but T table I have to use, therefore 5% significance I get. 5% significance. It means that like this. 95% confidence here. 5% means 0.025. 0.025. I want to find this. When you take 0.025 degrees of freedom, 10 minus 1, size of the sample considered 20, 20 minus 1, 19 degrees of freedom at 0.025, find that from T table. 19 degrees of freedom here, 2.093, 2.093. 2.093. This is value 2.093 minus 2.093. But you don't want to draw this one. Only 95% confidence, 5% significance means 2.09. From the table, identify. Then the standard error you need to calculate. Standard deviation 3.5. Square root of sample size 20. 20. Sample size 20. Then I estimate X bar plus 2 minus T table. Therefore, T alpha over 2. Z table is a T table T alpha over 2 multiplied by standard. Right. 11.5 plus 2 minus 2.093 multiplied by standard error 3.5 over square root of sample size. .5 over square root of 20, that value of 0.782 multiplied by 2.093. Right. Then I write here 11.5 plus or minus 1.65. 13.13. $9.87. Between that range. Calculation is not difficult. Right. Question number 5. The number of defective sheets of 30 paper packets has been provided below. 30 means large. 40, 50, 30 like that. Estimate the average number of defective sheets in the total paper packet production at 5% significance. But large sample, therefore 5% significance means 90% confidence. Right, now you want to take mean and standard deviation from data set. If it is, you use your descriptive statistic knowledge. Right. Using this data, calculate mean and standard deviation, sample mean and standard deviation. Use your calculator, right? Now estimation, using your calculator, take X bar as well as standard deviation. Formula we use, but here estimation, not descriptive statistic, we need. Therefore, by using your calculator, directly you take the mean and standard deviation. Otherwise, manually we calculate and X bar sigma X over N. Standard deviation, for this one we calculated sigma X minus X bar squared over N minus 1. That is variance. After that is calculated. Formula देखा right. Enter this data into your scientific calculator and take mean and standard deviation. Tanggal enter kalagan. Kalau kerana binari, kita hamarin bagi pulau. Maximum 2 minutes. Within 2 minutes you can enter. $15.4 mean value. $2.07. 2.0777 like that, no? Calculator දම්ම ගත්තාද? කැටලොග් නෑ නේද? remote එක remote එක කරලා remote එක කරලා n minus 1 කියන එක ගන්න. Otherwise sx standard deviation. Development Right, then estimate. Expand 15.4. 95% confidence, 1.96. Standard error, S over square root of n means 2.07 over 30 megapascals. Then 15.4 plus or minus 1.96 into 2.07 over square root of 30. Right, 2.07 over square root of 30, then multiplied by 1.96, 0.74. Plus 15.4, 16.1. 14.66. Between that range, 95% items will be between that range. Right, you should have the idea to use the scientific calculators. Again, later statistical packages, especially SPSS, statistical product for social science. In the calculator, normally you are working in DEG mode, DEG mode. Descriptive statistic you use SD mode. SD mode again, we calculate practice. Then I discuss REG mode as well. That is the regression mode. And also in your calculator, equation mode, EQN mode. Right, going to practice again. Right. Then you can see company 1, company 2. Two samples. Our next one we want to estimate. That's the second one. The small sample not T large sample not is a right. Then we take second one, estimation of the difference of population means. Estimation of the difference of population means. Second again, right. Take up in another kata. 11:30 we have another lecture, no? Right. 11:30 nothing. Zero, right. Estimation of the difference of population means. Okay, you segment the seat, attendance sheet.